Hi there, everybody. We're going to be going over the 9.4 section in this video. We're going to be mainly talking about circular functions. So we're still looking at SOHCAHTOA, their inverses, and we're going to be working with the unit circle and how to calculate each one of those values. So our first slide that we're going to start looking at is just basically a real-world scenario in which you can actually use the trig functions within your real everyday world and how that can occur. So let's take a look at slide 3. With slide 3, we're ultimately looking at our trig functions. Now, with each one of these trig functions, it's having an understanding that even though, yes, we are looking at sine, cosine, tangent, our cosecant, secant, and cotangent, it's understanding how this all plays a role within the unit circle. So when we are taking a look at our unit circle, and we draw out that unit circle, what ends up happening is that we will actually be able to draw our triangle within that unit circle. Now, every time that it comes in contact with this outside circle, this is the same thing as a point. So this is your x, comma, y. So this x, comma, y would be the square root of 3 over 2, comma, 1/2. And that would be your x and your y value. At that location is exactly where this tip right here would touch the outside corner of your unit circle. So understanding that this right here would be your radius, this would be your x, and this would be your y. Now keep in mind, your r is your hypotenuse, your x is your adjacent, and your y is your opposite. As we run through each one of these trig functions, you can see that if you're working with sine, sine would be your SOHCAHTOA. You're looking at opposite over hypotenuse. Opposite of theta would be your y over r, which you can see right over here. And that can be done for every single one of your trig functions, whether it's sine, cosine, tangent, or your inverses. Now the inverses are a little bit easier to remember because remember, you're just looking at the reciprocal of those. So let's start taking a look at slide 4. With slide 4, what we end up doing here is we are taking a look at the equation that basically helps the entire unit circle to function, which is x squared plus y squared is equal to 1. Now your hypothesis will always, your hypotenuse will always be equal to 1. That is your radius, which you can see right here. And the angles always have the initial side of the positive x-axis. So we're always going to be looking at the right-hand side of our x-axis. That's where we start. Notice it's based off of this being our 0 mark. Now, as we start working with our sine, cosine, and tangent, what we're ultimately looking at is what is coming out of our SOHCAHTOA. So for example, if we were to start with cosine for this problem, cosine is adjacent over hypotenuse. Adjacent would be x over hypotenuse, which is 1. So x over 1 for your cosine, which you can see x over 1 is the same thing as saying x. if you were looking at your sine. Now for sine, what will end up happening is you are looking at your opposite over hypotenuse. Opposite would be y, and your hypotenuse would be 1. So y over 1, which is equal to y. Tangent would be opposite over adjacent, or y over x. Now, from that scenario there of solving for your sine, cosine, and tangent, you would also be able to figure out what your inverse sines would be. So your secant, your cosecant, and your cotangent. Remember, it is just going to be the reciprocal of what you calculated for the initial 3. So the unit circle is a circle of radius 1 centered at the origin, and the point on the unit circle satisfy the identity of cosine squared theta plus the sine squared theta is equal to 1. So ultimately what we end up doing is looking at the exact same formula that we were looking at before, which was our x squared plus y squared is equal to c squared. And that is the same thing as our cosine squared theta plus sine squared theta is equal to 1. Now notice that radius will always be 1, and we would actually be able to start figuring out what this is, because remember, this would be our x, this would be our y. So in this example, what we're going to start doing is taking a look at our quadrantal angles. Now remember, quadrantal is whenever we have an exact angle at our x or y axis. So this would include our 0, 90, 180, 270, and 360. So we're going to go ahead and place our degrees right in there. So 0, 90, 180, 270, 360. Keep in mind you should be able to work with your radians. Radians of 0 would be 0. 90 would be pi over 2. Pi for 180. 270 would be 3 pi over 2. And 2 pi for 360. Now when we ask ourselves about what quadrant we are in, remember, this is a quadrantal angle, and that's for each one of them. Now, as we start taking a look at our cosine and our sine, in this case, what's going on is that every single time that we end up at a point, what happens is that the x value is actually your cosine, your y value is your sine. This means that each time that we take a look at our unit circle, this point right here is actually telling us cosine and sine. So when we start working our way through these problems, for 0, our cosine would be 1, our sine would be 0. When we take a look at our 90-degree angle, notice this would be 0, 1. 180 would be negative 1, 0. 270 would be 0, negative 1. And when we come back to 360, keep in mind, this is the same location as our 0, which would be 1, 0. Notice all we're doing is using the location of our points to find our sine and cosine. Let's take a look at our next slide. In our next slide, we kind of go over our traditional special right triangles. So this is going to be our 45, 45, 90 and our 30, 60, 90 degree angles. Keep in mind, our 45, 45, 90 degree angle would be a, and a square root of 2 on the hypotenuse side. And we have a, 2a on the hypotenuse side, and a square root of 3 on the long side of our 30, 60, 90. This is extremely important to remember and to be able to work with. So here we start looking at our 30 family. We started kind of describing exactly what we are kind of looking for within these problems. First thing is having an understanding of what exactly we are looking at. So first thing is we need to fill in the degrees for each one of our 4 areas. So we'll begin with 30, 150, 210, and 330. Now, once we have that done and we have that completed, we would be able to switch from degree to radians. First step would be going ahead and taking a look at our 30 degrees and understanding that that would be pi over 6. Pi over 6 would be our first quadrant. Now we can also take a look at what our reference would be for this problem. Because it's in quadrant 1, we would be able to go ahead and actually figure out our reference angle as well. So in this case, we're going to go ahead, 30-degree angle would be right about there. Now, as you can see, you can figure out exactly where that reference would be. Because we are close to that x-axis on the right-hand side, our reference would be pi over 6. Now, in order to truly determine our cosine and our sine, this is where a lot of times if you draw out the actual table that goes with this, it may be a little bit easier to kind of understand. So keep in mind, this is our sine, cosine, tangent. And we have 3 different angles. We have our 30, 45, and 60. Now, once you have everything lined off, it's just a matter of figuring out exactly what it is that we're looking at. So, this right here, our 30 would be, as in radians, this would be pi over 6. Your 45-degree angle would be pi over 4. And the last 60 would be pi over 3. We'll start off with our 30, which the sine would end up being 1 over 2, square root of 3 over 2, and the square root of 3 over 3. When we start working with the next column, which would be our 45, we're going to end up with square root of 2 over 2. Same thing is going to be seen within our cosine. And our tangent would just be 1. Final ones would be square root of 3 over 2, 1/2, and the square root of 3. This is extremely important because you're able to figure out exactly what these positions are in advance before even doing anything further. So here, even though we do have a rating of pi over 6, our quadrant is 1, and our reference angle is pi over 6. We're going to continue just filling in this left-hand side of our table before we go further. So 150 would actually be 5 pi over 6. And that would be in quadrant 2. This would also be pi over 6 as a reference angle. For 210, 210 is 7 pi over 6. And in that case, we are now looking at quadrant 3, but it is pi over 6 once again. Last step would be 330, which is pi, or 11 pi over 6. This would be out of 4. And that would be pi over 6. Now, our cosine and sine will be different for each one of these depending on the actual degree that we're looking at. So in this case, if we're looking at the sine, now our cosine of x and our sine of y are going to give us that coordinate that we're looking for. In this case, we're looking at the cosine of x being positive square root of 3 over 2 and a positive 1/2. As we start running into our 150, we have to keep in mind what exactly is going on with our problem. And in this case, we're going to end up with all students take calculus. And what it's going to do is going to help you identify where you're starting and where you're going. So for example, this would be our 30, and this would be pi over 6. Our S in this top left corner of our graph would be our sine. Now that could also be your cosecant, but you have to keep everything in line. So the first thing would be drawing out your 150. Now, understanding how to go from 150 to 5 pi over 6 is extremely important. First thing we're going to do is figure out what our reference angle is going to be. Now, if we know that 150 is the same as 5 pi over 6, 1 pi over 6 would actually be our reference angle. Now, our next step over here would be at 210. 210 gets us to this point right here. Now, in this case, as we're running through, notice we are in quadrant 3, and we are looking at pi over 6 as our reference. Remember, our reference is always trying to get as close as possible to the nearest x-axis, which is this portion over here. Now, even though we are looking at 7 pi over 6, remember this is 6 pi over 6, which there at that point will give you a pi over 6 as our remainder. Well, not so much the remainder, but the actual reference itself. So our last look is going to be in our final quadrant over in C. Notice it drops down and goes back up again. In this case, this is going to be your 11 pi over 6. With it being the 11 pi over 6, keep in mind that you're still going to be working the problems the exact same way. We just have to figure out the placement of where all these numbers are. So first thing would be at the 150, notice this would be a negative square root of 3 over 2, and we would still be at a positive 1/2. Quadrant 3, this would go as 7 pi over 6. Now, because we have gone and we are now looking at the lower side of our entire quadrant, what ends up happening is with this 7 pi over 6, we're actually going to end up with a slightly different number for 210. So our cosine here would be a negative cube root over 2. Now in this case, if we are in that third quadrant, keep in mind our y would be negative. Now they are going to remain the same, but it would be negative instead of positive. And the same thing goes with our fourth quadrant. In this case, we're going to end up with pi over 6, and there's nothing else for it to combine with. So at that point, we go ahead, mark it off, and determine the angles that are appropriate. So this over here, just keep in mind, helps to represent all students take calc. So let's take a look at slide 9. Slide 9 is very, very similar. The only real difference is we are now, instead of doing the 30 family, we are going to go ahead and do the 60 family. What I would suggest, go ahead, pause the video, and try to see how much you can do on your own. So in this case, we're going to start off with taking a look at our degrees. Our degrees here would be 60, 120, 180, 240, 300, 360. Now, usually what will end up happening is you can take a look at all of your different numbers, but you're going to notice that here, this is quadrantal, and this is also quadrantal. Do you need that within your 60 family of core numbers? No, you don't. So what we're going to do, just to save ourselves a little bit of time, we are going to get rid of Now, once we go ahead and move everything where we need to move it, we can start calculating our radians. We know that 60 is pi over 3. 120 would be 2 pi over 3. 240 would be 4 pi over 3. And 5 pi over 3. Now, each one of these is going to tell us a different scenario as far as what quadrant it's in and be able to kind of move things around. So in this case, it goes in order: quadrant 1, 2, 3, 4. Now, the position of these graphs do matter a decent amount. We're going to start off with our cosine, which in this case is going to be 1/2. Our sine would be the square root of 3 over 2. Keep in mind, these numbers are coming up from our x and our y values over here on the left-hand side. Now, as you become stronger and stronger in understanding what quadrant things are in, you will have an easier time at understanding what our graphs should look like and what our points would look like. In this case, because we're going into the second quadrant, keep in mind that side is going to be negative as far as your x. So this is going to be a negative 1/2, and our y is going to be 3 over 2. Now 240, notice now we're starting to head into the third quadrant, and in that case we're going to end up with a negative 1/2 and negative square root of 3 over 2. Last possibility would be quadrant 4. In this case, our cosine is going to be a positive 1/2. And you're going to end up with a negative square root of 3 over 2. I'll give everybody a quick minute to kind of take a look and take a photo if you feel secure. So number 10. In this problem, we have a 45, 90 degree angle. Whenever we have a radian, for the most part, what will end up happening is that the radian for 45 would be pi over 4. Now, keep in mind, we're not including 30, we're not including 270, we're not including 180, because those three will immediately take you in a direction that you're not going to want to go. So, first thing, if we're looking at our 45 degree angles, we're going to take a look only at the 45. So that means 45. Notice 90 would be a part of our quadrantals, so we're not going to include 90. 45 on top of that would be 135. After that would be 180. Keep in mind that's quadrantal. We have 225 and 315. First thing is understanding our quadrants. Notice this is for quadrant 1, 2, 3, and 4. And putting together our radians. 135 times 180 divided by, or 180 pi divided by the denominator, which in this case would be 4. So our final answer here would be 3 pi over 4. If we're looking at 225, that would be 5 pi over 6. Actually, not 6. Sorry about that. That would be 4. And our last term would be 7 pi over 4. Now, in order to find your cosine and your sine for this problem, one of the easiest ways to do it would be to go ahead and create your sine cosine tangent. And what you're going to do is you're going to fill it in for your 30, 45, and 60. So first thing would be understanding what it is, the numbers that you're going to end up having. For your sine, you're going to have 1/2. For 45, you're going to have the square root of 2 over 2. And for 60, you're going to end up with the square root of 3 over 2. We would then go on to cosine. And in cosine, square root of 3 over 2, square root of 2 over 2, and 1/2. Last one would be tan, square root of 3 over 3, 1, and square root of 3. Now, it is extremely important to especially know the reference angle when it comes to one of these problems. Notice on the left-hand side, we have an entire diagram, and it breaks down every single one of the problems and what the answer should have been. We're going to start off with our drawing. Our drawing states, all students take calculus. Now that's going to give you an order from quadrant 1 all the way through to quadrant 4. So at this point, we've worked with the 45 family. Our next step would be kind of understanding what is going on with our reference angles and how to make sure that the essential numbers are coming out. So first thing would be making sure that you're able to go ahead and break down what this portion of x would be and solve for y as well. So first thing you're going to do is have an understanding that even though we are looking at sine and cosine, they are going to have their own pi over 6, pi over 4, pi over 3, and pi over 2. Now, each one of these ratings is describing a different number. In this case over here, we have 0, 30, 45, 60, and this would be 90. Now you're going to end up having to fill this in. And as we start filling this in, everything will come together a little bit more. So this is our sine. Actually, these are all your degrees. We've got sine, cosine, and our tan. So we would end up with 0, 1, 0, 1/2 square root of 3 over 2, and the square root of 3 over 3. And you're going to continue working your way through these problems, and especially using the signs that you see on the top right corner of our PowerPoint. Let's fill in the rest for pi over 4, pi over 3, and pi over 2. Pi over 4 is a 45-degree angle. Now keep in mind this would be square root of 2 over 2, square root of 2 over 2. And our last answer for tan would be 1. Pi over 3 would be square root of 3 over 2. Square root of, sorry, not square root, just 1/2. And the square root of 3 would be that final answer. For our 90, this is going to be 0 and 1, and undefined. This does give a little bit of help and a better understanding to exactly what does our unit circle look like, how do we fill it in, and kind of goes from there. Now, this is extremely important, and I highly, highly suggest that at some given point between now and the quiz, be able to work with this problem and go ahead and determine how to fill in every single piece that we need to fill in. So, first thing would be going ahead, writing in the degrees. So we know this is going to be 0, 30, 45, 60. We've got 180 over here, 150, 135, and 120. Now, from that point, we're going to go ahead and continue working our way around. So this is going to be 210, 225, and 240. Over here we have 300, we have 330, and 315. Now figuring out the range, the radians would be based off of the position of our terminal line. So we're going to go ahead, we're going to start off with our 0. So our 0 is going to be 0. Actually, let's fill in our 360, because I almost forgot about that. And that's going to be 2 pi. Now, on the left-hand side, this is looking at 180 degrees, would be pi. And we're going to focus on our top right corner. This right here will give us the best idea possible for us to be able to understand and see exactly how everything works in radians. So first thing is, this would be pi over 3. This would be pi over 4, pi over 6. Now, once we have this, keep in mind, the radius that we're looking at is actually 1. So our points would be 1, 0, and this would be 0, 1. This would go in relation to our x values. This would be 1/2 square root of 2 over 2, and the square root of 3 over 2. Now what we've done here is the same exact value that will work with y's on the way back up. So this would be 1/2 square root of 2 over 2 and the square root of 3 over 2. Now this is extremely important because by understanding that first quadrant, you would be able to reflect everything needed as far as your points. So we're going to take a look at our 120 degrees, and we're going to take a look at the point. The point here is 1/2 comma square root of 3 over 2. Now because we're going from the right side of our graph to now the left side, it's almost kind of similar to a number line. Rather than the 1/2 being positive, we're now going to look at a negative 1/2. And the main reason for that is because now we are to the left side of that y-axis. We still remain with square root of 3 over 2, because notice we are above the x-axis. So this would be negative 1/2, negative square root of 2 over 2, and the negative square root of 3 over 2. From there, we're going to end up with a negative for each one of our x portions of our point. Because remember, we are to the left of our y-axis. We're going to go ahead, we're going to fill in the y portion of each one of these points, which would be the square root of 3 over 2, square root of 2 over 2, and 1/2. As we start looking at pi, or 180 degrees, this right here would actually be negative 1, 0. Now, as we start working our way down towards our third quadrant, what's going to happen is we are still to the left-hand side of our y-axis, but in this case, what's going to happen is we are going to remain with that negative x of each one of the points. So negative 1/2 would actually be over here, negative 1/2, negative square root of 2 over 2, and negative square root of 3 over 2. Now, instead of having a positive y, we're now going to have a negative y to go along with each one of these. This is due to the fact that we are now underneath our x-axis. So this would be negative 1/2, negative square root of 2 over 2, and negative square root of 3 over 2. Keep in mind, this would be at 270 degrees right here. And in this case, we are going to be going down to 0, and it would be at negative 1. The remaining points now, notice we're going to be to the right-hand side of our y-axis, which means we are going to have a positive x, but we're still going to have the negative y. So in this case, we are looking at 1/2 square root of 2 over 2, and the square root of 3 over 2. Notice we're still going to have a negative y, which would be negative 1/2, negative square root of 2 over 2, and negative square root of 3 over 2. Now, the next portion that we're going to fill in is going to be the radians portion of the entire problem, or the entire circle. We're going to begin with 30 degrees. 30 degrees would be our pi over 6. 45 would be pi over 4, and 60 would be pi over 3. Our 90 degrees would be pi over 2. Now, as we start rotating around the circle, what's going to end up happening is we're going to end up with 2 pi over 3, 3 pi over 4, and 5 pi over 6. Notice at 180 we would have pi. For 210, this would be 7 pi over 6, 5 pi over 4, and 4 pi over 3. At 270, we would be at 3 pi over 2. As we continue going towards 300, once again, this would be part of our 30-degree family, our 60-degree family, which would be over 3. And we would have 5 pi on top. Next would be 7 pi over 4. And 11 pi over 6. Our final portion is going to be our 360, which we know is going to be 2 pi. This is all extremely, extremely important in figuring out what it is that exactly goes all over our entire unit circle. Now, keep in mind, you can almost see in each one of these, we have a little area that says positive and negative. In this case, our positive would be our sign. And our negative would be our cosine. On the right-hand side, we're going to end up with a positive positive. So this would be a positive cosine and positive sine. As we drop down, we're going to end up with a positive cosine, but a negative sine. And in the left-hand corner, or in our third quadrant, we would end up with a negative cosine and a negative sine. Let's go ahead and take a look at our next slide. So how to use the reference angles to find the exact value for a standard angle. So to find the exact value of the following. So we start off with our tangent of 5 pi over 3. First thing that we're going to do is we are going to go ahead and take a look at our reference angle. Our reference angle is going to be the portion that is to the right of the 5. So in this case, this is going to give us a negative tan of pi over 3, which is equal to negative 3. Or sorry, not negative 3, I'm sorry. Negative square root of 3. Now, we really have to just take a look at the entire thought process that occurs behind us figuring this out, first thing would be finding the reference angle. Our reference angle would be, if we have 5 pi over 3, keep in mind this is going to be within our fourth quadrant, and we're going to be looking to get as close as possible to our x-axis, which would be at 6 pi over 3. With it being at 6 pi over 3, we're going to go ahead and we're going to be 1 pi over 3 away from our actual reference angle. For the tangent of reference angle, we're going to be looking at the tan of pi over 3. And that tan of pi over 3 is going to give us the square root of 3. We're going to go ahead, and our next part is going to be the quadrant of the angle. We're going to go ahead and look at what is pi over 3. Pi over 3 ultimately is 60 degrees. So if we multiplied that by 5, we're going to be looking at 300 degrees, which is our fourth quadrant. When we're looking at our fourth quadrant, the sign of tangent in the fourth quadrant would be a positive negative. Remember, this is what we were talking about before when we were referencing that this portion over here where we have our cosine being positive and our sine being negative. Okay? In this case, because of what we're running into, this would actually end up being negative. So that's how we end up with a negative square root of 3. So what I would suggest, go ahead, take some time, try to work on this next slide on your own, and we will come back in a second in order to continue working on this slide. So as you can see, we can go ahead and start working on this problem. The first thing that we're going to take a look at is laying out our entire table. Our table here is going to be all students take calculus. And this is going to give you a better idea of exactly what it is which is going in each one of these quadrants. So let's start off with all students taking calculus. Now, we're going to go with this top left corner, and we're going to start off with the S. What this means is that this is going to be our sine and our cosecant. And in both cases, both of these would be positive. When we're taking a look at the T, this would be our tan and cotangent. And we're going to take a look at our C, which would be our cosine and our secant. Now, understanding which quadrant this is going to be in is also an extremely important factor. So keep in mind we have quadrant 1, 2, 3, and 4. Understanding the quadrant that it's going to be in is going to help identify whether it's going to be positive or negative. So let's start off with our first problem. First thing would be identifying exactly where this would be. So understanding the quadrant. If we're looking at sine minus 45, first thing is understanding the quadrant. We would be in quadrant 4. Quadrant 4. Now, would this be positive or would this be negative? In this case, this would be negative. So what would be the reference angle that we would be talking about? Well, in this case, our reference angle would be 45. From this point, we can then evaluate exactly what it would be, which notice here it's going to be a negative square root of 2 over 2. So let's take a look at our next problem. Our next step is going to be our quadrant for cosine. Quadrant for cosine would be quadrant 2. And this would fall as being negative. Now, our reference angle, remember, this is going to come off of us taking a look at the back portion of our numbers, right, of our equation, and determining what would be coming closest to our x-axis. So for 120, notice that would come closer to 180. So the distance between 120 and 180 would be a distance of 60. And the same can be done for every single one of these numbers. Notice 5 pi over 6. Closest would be 180, which would be 6 pi over 6. So there is a reference of pi over 6. 4 pi over 3 would be pi over 3. Cosine of 315, notice the closest would be 360, which would be a distance of 45 degrees. Sine of 120 would actually give us a distance of 60 degrees. Cosine of 6 pi would actually give us a multiple of our quadrantal. Remember, pi is 180, 2 pi is 360. So we would actually be right on 0 for it being on that axis. In this case, we're going to go ahead, look at the next one, which is the tan of 180. Our quadrantal, once again, would be 180 degrees. Last one would be 5 pi over 4. This would be closest to 4 pi over 4, which is our 180. And our reference angle would be pi over 4. Now, let's work our quadrants and our positive negatives. As we're working the left-hand side, we're going to go ahead. Tangent of 5 pi over 6. This would be our quadrant 2, which would be negative. Secant would be quadrant 3, negative. Cosine would be quadrant 4, positive. Quadrant 3, negative. Cosine, now keep in mind, this is cosine of 6 pi. Remember, this ended up being directly onto our quadrantal, right? This is falling on our 360. So we would describe this as quadrantal. Because once again, it falls right over here at 1, 0. our tan of minus 180. Notice once again that is a quadrantal. But because it's being on the 180, you are no longer on that right side. You are actually on the left side. Remember, this would be 1, 0. This would actually be negative 1, 0. Last one would be cosecant 5 pi over 4. This would give you quadrant 3, and this would be negative. Now, in order to evaluate exactly what our answers would be, keep in mind you are plugging all of these in together in order to fully understand where you would end up. So, cosine at 120 would leave you with negative 1/2, negative square root of 3 over 3, negative 2, square root of 2 over 2. We're looking at sine minus 120, which is a negative square root of 3 over 2. 0, 1 would fall onto that quadrantal. 80 would fall onto our 0. And our cosecant would give us a negative 2 square root of 2. Now keep in mind, you will have to work that square root of 2 out of the denominator. So we're going to multiply both the top and bottom by the square root of 2, which is going to leave us with negative 2 square root of 2 over 2, which is going to leave us with a negative square root of 2. So we're going to go ahead. Now here we evaluate 6 trig functions at each one of our different angles. Okay? Now, highly suggest give you a minute or two to kind of work through this. I will more than likely be creating another video just to go a little bit more in depth into this, but don't want to make this video even longer than it has to be. Slide 17. There are a couple practice problems for you to work with. And on the very back page of all of your slides, you already have your unit circle. Highly suggest become very familiar with it the most that you possibly can. This will be extremely beneficial to you. I can't stress this enough. We will be going over this section as a whole a little bit deeper, but this does give you the basics of this section.